120 Fargate tasks, 30 infrastructure ENIs, and a 24 subnet with only 251 IPs. New tasks stuck pending with 0 error messages. The root cause? IP exhaustion. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Amazon Web Services Fargate. Fargate is like renting individual apartments instead of buying an entire building. You bring your containers, specify how much CPU and memory they need, and Fargate runs them without you ever seeing a server. The core abstraction is the task definition. It specifies the container image, resource requirements, identity and access management roles, logging configuration, and networking mode. Elastic Container Service schedules these tasks onto Fargate-managed infrastructure. Here's a typical Fargate task definition. It declares the container image, CPU and memory, identity and access management roles, environment variables, secrets, logging, and health checks. Each task gets its own ENI and resource isolation. Fargate tasks run in OSP mode. Each task receives its own elastic network interface with a private IP in your virtual private cloud subnet. This provides virtual private cloud-level security controls, but requires careful subnet planning to avoid IP exhaustion. This CloudFormation snippet sets up private subnets, a NAT gateway, virtual private cloud endpoints for elastic container registry, and security groups. Notice the 20 subnets. That's 1491 usable IPs per AZ, which is critical for avoiding IP exhaustion at scale. Fargate pricing is based on vCPU and memory allocated to running tasks, billed per second. Most production deployments overspend by 30–50% due to inflated resource requests. Right sizing based on actual utilization is the biggest cost saver. This Python class calculates Fargate costs. It shows how to compute hourly and monthly costs, including a 70% discount for Spot. Use this to model your own workloads and find savings. Production Elastic Container Services on Fargate require a deployment configuration that handles rolling updates, health checks, and auto-scaling. The circuit breaker monitors task health and automatically rolls back if new tasks fail to start. This CloudFormation defines an elastic container service with circuit breaker enabled, auto-scaling with a 65% CPU target, and health check grace period. The circuit breaker is the most important production feature. Without it, a bad image push replaces all healthy tasks. Since Fargate provides no SSH access, all observability must be configured through the task definition. FireLens routes structured logs to multiple destinations, Container Insights provides per task metrics, and X-Ray adds distributed tracing. This task definition adds an X-Ray sidecar and a FireLens log router. The log router uses FluentBit to send structured JSON logs to CloudWatch. Notice the depends on condition, the log router must start before the main container. Fargate tasks transition through 7 states. The provisioning state is where the magic and the pain lives. That's when Fargate allocates compute, pulls the image, and attaches the ENI. If the image pull takes more than 2 minutes, your task gets recycled. This event bridge rule captures task state changes and sends alerts. Wire this into your alerting pipeline on day 1. A task sitting and pending for more than 30 seconds indicates something is starving. Fargate gives you 20 GB of ephemeral storage by default. That sounds generous until your ETL job downloads a 10 GB model file and tries to write a 15 GB result. The task runs for an hour, then exits with no obvious error. Here we set ephemeral storage to 60 GB explicitly. We also mount an elastic file system volume for persistent scratch space. Always set log rotation and monitor disk usage inside the container to catch silent failures. Most Fargate builds explode because teams deploy without a sizing strategy. Use CloudWatch Container Insights to observe peak CPU and memory, then right-size each task definition. Pair with auto-scaling to cut costs by 40–60% without code changes. This auto-scaling policy maintains a 50% CPU target. It scales out when CPU exceeds 50% and scales in when it drops. Setting min capacity too high wastes money. Use scheduled actions to drop to 0 at night for dev environments. Fargate tasks that complete exit instantly, but their associated resources linger. ENIs, CloudWatch log groups, and ALB target group registrations remain orphaned unless explicitly cleaned. Run a nightly Lambda to delete orphaned ENIs. This Lambda function deletes orphaned ENIs from stopped Fargate tasks. It filters for ENIs with description, Amazon Web Services Elastic Container Service asterisk, and status, available. Always filter by status to avoid deleting ENIs attached to running tasks. This is the same issue we highlighted at the start. Here's exactly why that happened. Each Fargate task requires an ENI with a private IP. The team used 24 subnets with only 251 usable IPs per AZ. With 120 tasks running and 30 ENIs consumed by NAT gateways and ALBs, the subnets were exhausted. New tasks could not be placed because no IP addresses were available. The fix was to expand subnets to 20 using secondary CIDR blocks, providing 4091 usable IPs per AZ. We added a CloudWatch alarm on the available IP address count metric at 20% remaining. Now, we monitor subnet IP utilization and alert before exhaustion. Using /24 subnets for Fargate is a common mistake. Each task consumes one ENI with a private IP. A 24 subnet only has 251 usable IPs, which is quickly exhausted by tasks and infrastructure. Always use or larger subnets for Fargate workloads. Without the circuit breaker, a bad image push replaces all healthy tasks with failing ones, taking down the entire service. Enable deployment circuit breaker with rollback to automatically revert to the previous task definition when new tasks fail. Over-provisioning CPU and memory is the biggest cost mistake. CloudWatch shows 15% CPU utilization, but you're paying for 4 vCPU and 16 GB. Right-size tasks to 1.3x actual P95 utilization to save 30–50%. The article uses platform version, latest in CloudFormation, which is risky for production. Always pin to a specific version like 140 or 130 to avoid unexpected breaking changes during Amazon Web Services rollouts. Check the Amazon Web Services documentation for the latest stable version. Fargate spot tasks receive a 2-minute SIGTERM warning before interruption. The article mentions handling SIGTERM but doesn't show code. Here's a Python example that catches the signal and performs cleanup before exit. Fargate does not expose the Docker socket, /var/run/docker, sock, so you cannot run Docker in Docker or use tools that require direct Docker daemon access. This is a common gotcha for CI/CD pipelines that try to build images inside Fargate tasks. Instead, use Amazon Web Services code build or Elastic Container Registry pull-through cache for image building. When debugging Fargate issues, start by checking the task stop reason with describe tasks. Then check subnet available IPs. Verify the execution role has the required policies. Finally, review CloudWatch logs for application errors. Let's run through some common interview questions. What is Amazon Web Services Fargate and how does it differ from Elastic Compute Cloud? Fargate is serverless compute. Amazon Web Services manages infrastructure, you define tasks. Elastic Compute Cloud requires managing instances. How would you optimize Fargate costs? Right-size tasks, use Fargate Spot, consolidate containers, create virtual private cloud endpoints, stop non-prod at night. A Fargate service has tasks stuck in pending. Walk through diagnosis. Check stop reason, subnet IPs, execution role, security group, virtual private cloud endpoints, resource quotas. And a few frequently asked questions. Is Fargate truly serverless? Yes, Amazon Web Services manages servers, but you still configure networking and identity and access management. What are the max resources per task? 16 vCPU and 120 GB memory. Valid CPU, 0.25, 0.5124816. Can Fargate tasks communicate with each other? Yes, via private IPs, service discovery, or internal ALB. To recap, Fargate removes server management but requires careful networking, cost, and observability planning. Always plan subnet CIDR blocks for peak task count, right-size tasks based on actual utilization, enable circuit breaker, and use virtual private cloud endpoints. Ready to go deeper? Up next, Amazon Web Services Elastic Kubernetes Service, then Amazon Web Services Simple Queue Service and Simple Notification Service, then Amazon Web Services CloudFront and Route 53. Find them all at thecodeforge.io. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.